Welcome everybody to one of our little sort of webcasts and web chats. I'm delighted to have Grigore Rosu from Runtime Verification with me today. So welcome, Grigore. Thank you so much for your time.
Hi, John. Thank you for having me.
For those of you who don't know me, my name's Jon Moss. I work for the Cardano Foundation, and we have got some community submitted questions for you today, Grigore. So we're going to run through these and see how we get on. So first question. It's a little bit of a long sort of introduction to this question. So K framework may be used to semantically translate one supported language into another one. This feature is the cornerstone of the idea that Cardano will allow users to write smart contracts in different existing general purpose languages with the help of IELE. The complication here is that non-blockchain specialized common languages are often included rich and deeply interlinked standard library. It is quite a long introduction, this. In your opinion, what would the possible solution be for a deployed code? Either it allows to use any imports and K resolves them transitively, and then how to avoid deploying half of a standard library with each contract? Or should it only native built-in syntax structure for a language without allowing any imports, so devs would manually add any required utilities with each contract?
So both of these approaches are possible. The plan is indeed to take any programming language for which there is a formal semantics in the K framework and generate a compiler from that language to IELE, and then we'll run IELE natively on the Cardano. Indeed, the question is how to deal with libraries, and as the question very well puts it, one approach is to have built-in libraries in IELE and to provide only those, and any language will be stuck to those, or to have implementations of various libraries in IELE or translations from those libraries. Those libraries themselves can be implemented in something like Solidity, for example, a higher level language, and then or Plutus, and then those can be compiled to IELE and then reused over and over in many other languages. So I think what will happen in the end will be a mixture of the two. Of course, we'll have to experiment with it, and user input will be extremely useful. But what we have in mind right now is to have a basic set of functionality that will be provided by IELE already, like how to check balances of different accounts, for example, or how to make a transfer from account A to account B. So there will be some very basic functionality provided by IELE itself, and then the rest will be just implemented in IELE, and most likely to be implemented in higher level languages and then translated to IELE. And recall that IELE has a built-in, it's like LLVM, so it has a built-in ABI, if you want. There is a very clear way how to call functions, right? So you have functions, so a whole library can be provided in an account, right? And then you can just call into that account and call functions by their name and arguments in IELE, and this way make use of them in the higher level languages. But yes, there will be a way. When you define the semantics of your language in K, there will be a way to hook commands or statements in your language, or function names in your language, to library names that are already provided by the IELE library. We already do that frequently with other languages, not on the blockchain, like with C, for example. Our semantics of C calls the glibc, which is a native implementation of the C library. And we have an interface how to connect the language semantics to that library. So we'll use the same idea with IELE. So we are going to have a library implemented in IELE, either generated from higher level languages or even directly by hand in IELE. There will be also some built-in functionality in IELE already for some basic operations, and then there will be a way in the language semantics that are defined in K to hook operations, symbols in your language to these library functions.
That's a very good answer, very comprehensive too. So question 2, we might have covered it. You might have covered a little bit of this, so forgive me if we have. So building on the previous question, but now about K in general. So without blockchain, semantic translation may be used to fully convert a program in one language into semantically the same program in another language. But all higher level languages, sooner or later in their library code, rely on native calls to the OS or their own runtime. And those calls are not technically part of the language semantics. So, for example, Java library, for instance, may perform native calls to the JVM in order to perform a fast CPU math operation. So the question, is there already a known solution for this problem on how to map native calls to one VM or OS? So, for example, JVM, so into calls to another VM or runtime. Or was it perhaps already tested and solved with K? So what do you think?
This is a very good question. And I'm very impressed with the quality of the users. I can see that quality, just looking at this question. It's a very deep question, very good question. So here is the answer. The problem, as I also mentioned in my previous answer to the previous question, so we have already solved this problem for languages like C and Java. We already have the semantics of C and Java. And what we do, as I mentioned also in the previous question, is we have a general mechanism to hook. We actually call it literally hooking, right? So we hook constructs in your high-level language for which you have a semantics. You hook those to native implementations, and like the native library. In C, we hook to the glibc. Right, and it's a very simple mechanism. Well, actually, it's simple to use, but it's very intricate how to implement properly. But we made it work for C and Java, which is why I'm confident that we'll make it also work with IELE. In short, the idea is the following, because whoever asked this question expects a deep answer, because it's a deep question. So the main idea is the following: how to move state from the semantics of your programming language, right, to the native environment where you execute native calls, and then how to get the results of those native calls back into the semantics. And this is very tricky. We spent almost a year actually to get this to work. Wow. And it's very intensive. So in short, the idea is to take the arguments of your function that you pass to your function. I'm talking about C now, right? Because if you make things work with C, you make them work with any other language. So C is the trickiest. So you take a function, you take the arguments of that function, and suppose that you want to make a call from the semantics into the native library, right? So what we do then in the semantics, we do a reachability transitively closed analysis of the memory in the semantics, right? We start with those arguments and we go and reach all the memory that those arguments can reach regarded as pointers, right? And this way we get a portion of the memory that might be needed by the native call. And we create then an environment for the native call to execute natively with exactly the same map of memory. All right, and then we make the native call. The native call may reach, all these locations in the memory, may change them, and then we take back the memory after the native call terminates. We assume the native call terminates. If it doesn't terminate, then the whole thing will not terminate. So we have to be very careful how we design the libraries. But then we take the result back and redistribute it or update the memory of the semantics. So anyway, the short answer is that is a very serious question. Took us almost 1 year to get right, and we've made it work for C and Java, and I am very confident that we'll make it work for IELE as well.
Fantastic. I'm glad the questions are good ones. So this is very promising for the other ones that we've got coming up.
Very, very good question. Very good question.
Excellent. So question 3. Cardano is planned to have at least 2 computational layers of layer VM, so KEVM and IELE. It's often explained that IELE is the one that will allow to use different programming languages by semantically translating those languages into native IELE code. But if K allows to automatically generate semantic translators for any supported languages, and Solidity is a supported language, does it mean that any other supported language may be translated into Solidity? and also executed on KEVM?
So the answer is yes, in principle, yes. So this semantics-based compilation, the way it works is that it takes a programming language semantics and the program and generates another semantics, which is very specialized for that program. Or it specializes the semantics of your language with the program, and you get a semantics which is very customized for that program. It only knows how to execute that one program. And then we use the IELE backend of K, in this case, to generate IELE binary. But this backend, so actually the intermediate semantics, is almost as simple as a finite state machine, which is very easy to translate into any language, in particular to IELE. So yes, we'll focus on IELE because IELE is the way we wanted it to be. We like it, and also because it will be easy to adapt our LLVM backend of K. Remember that IELE is an LLVM-like VM for the blockchain, right? So it will be very easy to take our LLVM backend of K and generate IELE instead of LLVM, but it should be easy to generate any. We can generate directly KEVM. We don't even have to go through Solidity because it's just a finite state machine. You can generate code from a finite state machine in almost any language. But to answer the question, yes, you can just as well generate Solidity, a finite state machine in Solidity, and then compile that to EVM and run it on any blockchain. So SBC, semantics-based compilation, in principle works with any language as a backend, as a target language, simply because it goes through an intermediate stage where you generate a finite state machine, almost like representation of your program.
Very good.
But we'll focus on IELE because of all the benefits of IELE. So yes. IELE will be the first one that will make work, but there is absolutely no technical limitation to make it work with KEVM or any other language for that matter.
Understood. Thank you. Great answer. Mm-hmm. So question 4. So a lot of tutorials may be found online that teach Solidity programmers on how to perform manual gas cost optimizations in their code, so that logically the same operations consume less gas by utilizing cheaper opcodes. So this is arguably an awful practice that prioritizes cheaper code over readable and obvious code. But this is an instrument of free market and an inevitable result of liquidizing the computational power. How, in your opinion, K, IELE, and multiple level semantic translations are compatible with such a practice? Do you think it would be possible to estimate gas costs for a contract in any language without moving it all through the levels of compilation first? Could K compilers in theory be parameterized to automatically perform specific gas-related optimizations? So, for example, Solidity compiler allows to perform different compilations for contracts with different planned calls rates. So it's a sort of a double question, really. What do you think? Yes. What do you think?
Yes, and again, very, very good double question, or very good questions, depending how you look at it. So actually, this is one of the intended original benefits of IELE. We wanted to inherit all the good features of LLVM. And one of the features of LLVM that people like a lot is all the optimization pipeline that it offers, right? So in LLVM, you compile from a higher level language, let's say C, right? Using a translator like Clang, for example, from C to LLVM. Then you get an LLVM, which is correct, because the translation is very simple. You can even prove it correct. And we are going to actually do this automatically. So we are going to, to make sure that it's correct. But the point is that the first LLVM code that you get, or in our case, IELE code that you get, is not meant to be very efficient. It's meant to be optimal. It's meant to be correct. Sorry, but it's not meant to be optimal. But then the philosophy of LLVM is that you take LLVM code to LLVM code, and you apply an optimization, right? So each optimization is like a pass from LLVM to LLVM. You apply that optimization and turn the LLVM code into some better LLVM code according to some metric of better, right? And then you keep doing that, right? And you optimize the code from LLVM to LLVM up to a point where you say, okay, I'm happy with this. And then from there, you generate native code. In our case, there will be no native code because it's still IELE, right? But since IELE is in principle LLVM, right? The hope and the original plan was to enable all this optimization pipeline philosophy of LLVM to IELE. All right, and some of the optimizations will be with respect to gas. All right, so we take a IELE program, and the challenge there will be how to generate a equivalent, mathematically equivalent IELE program, but which consumes less gas. All right, so that's the philosophy how we want to, how we want to deal with optimizations in IELE, and in particular with gas optimizations. This is, I think, the answer to the first question. So yes, it will be possible. The second question, one of them, right? So that's how we intend to do gas optimizations. But there's another good question here, which is, can we estimate how much gas an original high-level program, let's say in Solidity, takes without going through all the compilation pipeline?
Yeah.
And my answer to that is probably no. If you want to have a very precise estimation, then you will have to go through all this optimization pipeline.
Yeah.
But I don't think that is a problem, because this optimization pipeline, it should be quite fast. We do not expect that to be slow, and you can do it locally before you deploy your contract, right? And I think you want, as a user, to actually know the exact binary that you run, how much cost it takes, how much gas it takes, and not some high-level, language that changes weekly, like Solidity does, right? So you'd rather analyze the binary.
You need that confidence.
Yeah. Exactly, to give you more confidence to analyze the actual binary. And which brings me to another interesting point, an important point, which was, again, part of the design, why we even use the K framework to design IELE first place, is because the semantics of IELE in K already includes, the gas model, a gas model in it. So we can calculate, if you give me a IELE program, I can calculate the exact gas it takes as a symbolic expression of the input. All right, so you may have a program that may have a loop that depends on an input, right? So then your gas will be some complicated non-linear, sometimes linear, but not always necessarily linear expression on the inputs, symbolic inputs to your program, right? So we can calculate that exact gas that it takes in order to execute this program. And this could actually be even advertised by contract owners, right? So if you have a contract, a IELE contract, and you want to publish it, right, you can also tell your users how much gas your program is going to take as a mathematical expression of the input. So whenever they initiate a transaction and they call into a function, in your contract, they can calculate statically upfront how much gas that is going to take without executing the code, because we already give them the mathematical expression that tells them exactly how much gas it takes. So yeah, so I think my position here is that you should not trust the higher level languages that change all the time. One of the reasons we have IELE is exactly, and also why there is one of the reasons we have EVM out there is exactly because it gives you a low level, fine grain model to calculate the gas that a program takes, and we should take take advantage of that and take it seriously. While the high level languages change all the time, and it's hard to keep up with. With them, especially in terms of gas consumption.
Yeah, thank you. That sounds very good. And I'm sure that's answered his question or her question. We've got some people's names, not everybody's. So I have got the next question. So this is from Mark Jackson in the forum. Is there a way to run a private testnet node?
Oh. I may, so here's something I may not know the answers to all these questions, because it also depends a lot on how we set up the network. It's, this is more like a network question than IELE itself.
Yeah.
So this is something you want to edit, or maybe I can ask other people, in my company about that.
No, that's fine.
Yeah, in principle, if we set up the testnet in a way that people can add their own nodes, then it should be possible. If not, then probably not, right? But it's completely orthogonal to IELE itself.
Okay.
So this is, as I said, I may not be able to answer all the questions simply because.
Completely understand.
we have absolutely, we work closely with IOHK to put together the testnet, and they are in charge of the network and of the Mantis, right? So all the software that is responsible for the communication between nodes, right? And IELE is really only the VM that executes the code on the node, right? So you see, so as soon as we get the code to the node, we can run it. Whether the node is private or not, that's an outside question.
That's a good answer. Good answer. So next question is regarding error messages on the testnet. Is there anywhere or the best way to report any error? And this was asked by a user in the forum on how to solve or handle a message that came up on the testnet.
So IELE has its own way to report errors and to throw exceptions. Has some built-ins. IELE I think it's return or exit. We haven't really spent a lot of effort trying to design good error messages. We were more interested in the correctness and to have a clean way to exit whenever bad things happen. I guess we should just add more documentation here about error messages. In principle, you see, this is the benefit of doing something semantically in a framework like K. It's very easy to add such error messages. In the C semantics, for example, since we have a tool, a runtime verification called RVMatch that is powered by the C semantics, actually it's just exactly like IELE, but running C, right? The C semantics. There are lots of requests from users for error messages. C has all this undefined behavior business. It's a very complex, error system. And users literally wanted very specific error messages about very specific undefined behaviors. So I would say that was all driven by users, which is why I would encourage actually users of the testnet to tell us, hey, I would like to have this error, keeping in mind that it is very easy for us to add error messages. Now there is also the communication with the network, right? So IELE can report an error, but then that error needs to be communicated right back to the user.
Yeah.
So that's right. It's a double layer that we have to worry about. But I think the short answer is it is very easy to add error messages, but we need help from users to tell us what kind of error messages they want.
Okay. No, that's really good. Very useful.
Mm-hmm.
So next question, would it be possible to have some real-time dashboard with key metrics for the testnet and timestamped status updates? So for example, node failure, random behavior, working on something. And this is from a discussion of community members in Telegram in one of the chat groups.
So again, this is a question more for IOHK than for us. Because they designed the actual testnet and the user interface. I think it's more like a user request here. They would like to have that rather than a yes/no answer.
Yeah.
So yes, it should be possible to have a nice dashboard with the metrics and everything. I'm not sure what that would take to implement at IOHK, because as I said, they are responsible for the. I mean, we split the work, right? We're responsible for the actual VM and compilers, how to get to execute the code, and they are responsible for putting things together in the testnet.
Let me see if I can just make the questions more useful and accurate. So let me have a look at this one. Where will compilation from source to K to smart contracts happen? On the deploying client or on CL nodes?
Yes, very good question again.
This is from Marcus.
Yes. So thank you, Marcus, for the question. So definitely, once you have a case semantics, let me ask another question, which is related somehow. Where do you even store the case semantics of high-level languages? Like say Solidity 1.2.04, right? So where is that semantics stored? Ideally, I would personally like to store the semantics themselves on the blockchain, right? You have like an account on the blockchain and an address on the blockchain, and there you have the Solidity 1.2.04 or Plutus 1.01, right? So everything is on the blockchain, including languages. And then whenever you do SBC, semantics-based compilation with a particular language, so you want to write a contract now in Solidity 1.2.04, right? You have to grab the semantics and generate the IELE binary, and you can do that locally, right? There is nothing to stop you from doing it locally for testing purposes and for playing with the code. But then you may have no guarantee provided by the blockchain, right, that your binary is consistent with the actual program according to the language semantics. Because who knows, maybe you click by mistake on another account and you got the Solidity 1.2.05 semantics instead of 1.2.04, right? So there is that possibility, and then you generate some binary, and how do you you cannot blame anybody then, that binary is not the expected binary. On the other hand, one can imagine, a nice environment where the client, could be responsible for grabbing the exact semantics of the k-semantics of the language that you want, and then do the SBC internally and using the actual client code, and then give you a binary. And now, provided the client is correct, and it should be at least audited seriously by some reputable auditors, or even verified, the client itself can be verified, then you have the guarantee that you use the right semantics with the right program, with the right implementation of SBC itself, and you got the right binary. So I would say, from my point of view as a designer of K and SBC and the entire infrastructure, it can happen either way, right? You can either use SBC locally, provided that you get the semantics from somewhere of your programming language, and then you generate a binary, provided you trust the binary. You can also test the binary or even formally verify the binary locally before you deploy it. But it can just as well be done by the client. Of course, that will increase the complexity of the client. So I personally do not expect at the beginning to be done in the client, because I think that will significantly increase the complexity of the client. I think would like, at least initially, to experiment with SBC in the simplest possible way to use it, which is just use it locally on your machine. Or maybe we can provide some server, some web server somewhere where people can pick the semantics, pick the language, SBC, get the IELE code, and then they just run it locally.
That sounds good.
Or something like that. But I agree, it would be nice to have it in the client, or even I don't know, maybe even SBC itself could be in some address on the blockchain.
Yeah.
So you can have the language semantics and then SBC itself, and then you say exactly which version of SBC, of the SBC tool you use with which version of Plutus or Solidity, and then you generate binary, IELE binary, in which version of IELE as well, right? So all this can be on the blockchain for clarity. But I would say these are things that we can experiment with later on. For now, I would like to just see SBC working and replacing the compilers as we know them. We can have exactly the same questions. We can ask the same questions about compilers in general, right? So where do you compile your program? You want to compile it in the client? You want to compile it in your own?
Exactly this. And his actual next question from Marcus as well is, where will compilation from source to K to smart contracts happen? So
right.
Right,
exactly. So the same question. It can happen anywhere, but for now, I would like it to happen.
That would be good.
Yeah.
So next question, we've got a few more, so we're not too many, so I think we're good for time. Are there any tutorials and introductions, sort of learning information out there to actually verify a EVM smart contract and how to deploy it? So there's a lot of people who are interested in resources for learning. So he was saying here, So this is from Dominic on the forum. I was wondering if there are examples or tutorials to verify a Solidity smart contract using the K framework and how to use the wallet to deploy the contract to the testnet.
So we are working hard on adding more and more tutorials. And for now, we have two, I think, which could give you a good head start. So if you go to our runtimeverification.com website, under solutions, there is a smart contract verification solution. And there are links to our GitHub repositories. We have verified lots of EVM contracts, and we wrote reports for how we verify them. And there are links to everything, links to the specifications, links to how to even run, how to install K, even how to run the whole thing. Because many of our clients, because you probably know that we offer this service at Runtime Verification, we verify smart contracts for EVM smart contracts, and soon hopefully IELE, but for now just EVM contract as a service to different clients. And they wanted to be able to run the proofs themselves, right? So we have full instructions, all open source, all public, right? Full instructions how to run the smart contracts. And we have, I think, 5 or 6 of them. The latest one is the Casper protocol itself, the Ethereum Foundation Casper, which is implemented in Viper, then compiled to EVM, and we verify the actual EVM. So there are instructions how to run all of this. So I think, for a technically minded person, it should not be hard to just follow those instructions. And for some people, that can be the best possible tutorial.
Yeah.
Okay, hands-on. And another thing we are doing right now, also with with a lot of help from IOHK, and we're also discussing directly with the Director of Education, Lars. But one thing we are doing on our site here, Runtime Verification, is to write blog posts that popularize formal verification, explain even why formal verification is important, and then what's the big picture of formal verification, how to start, how to come up with the specification, the entire process. And this is linked to also from that web page I mentioned, or also people can go to the blog on our web page. So on the web page there's a blog link, and then there are lots of articles there. And I think, actually, let me check it right now. I think the last blog on our web page could be exactly that. If you go to blog or runtimeverification.com, then the last post we have is called "How Formal Verification of Smart Contracts Works."
Perfect.
And it has several pages of very informal explanation. Actually, I would start with that. If somebody wants to learn how formal verification of smart contracts works, I would start with this page and then look at the actual proofs.
That's great.
Yeah, there's also a little video there. So so we are doing our best to improve the documentation. But again, this is some place where we need feedback from users, because they always help us, telling us what we need to do.
Sounds good. Thank you very much. Okay, we've got one more question, I think. So can you please tell us about your general impression from your work with Cardano or other projects and smart contract technologies? What's your opinion of the future of smart contracts? What could it look like? And, if you're speculating completely freely, would languages get more and more specialized? Do you think, let's have a look here, or would there be always a logical gap between general purpose computation and highly specialized blockchain code?
So if I'm allowed to speculate.
Speculate and look into the future.
Look into the future. So first of all, the reason we came up with IELE is because we wanted a language to have all these good features that we already talked about. But there is one other important feature that I didn't mention, which is human readability, right? So when you call into a contract, let's say an EVM contract, right, you are actually pretty much entering a binding contract, right? Because if that contract takes your money from your account, then you lost everything, right? You have to really trust that code. But the problem with the EVM code is that it is not human readable. You look at it and you see only push, pop, dump, add, and and it doesn't make any sense for a human to read that code. And I didn't like that. I really wanted my contracts to be readable, right? I have that problem also with lawyers, right? I have this company, Runtime Verification, and sometimes we have to deal with lawyers, and they write these documents, and sometimes I don't understand them, and that bothers me, right? And I have to sign the document. So same here, right? So I would like a language where I look at the contract that I'm getting into, in a binding fashion. I look at it and I want to understand what it says. So I think they must be human readable. And even at the level at which they execute, not necessarily, like you may say that, well, you have a higher level language and you understand things at that higher level language, but then you compile it down, right? And if you trust the compilation and so on, fine, yes. But then it means that you need to always have the higher level language, the program in the higher level language available, because if somebody calls into the contract, they'll need to know, they will need to redo all this, to make sure that the actual binary they call into comes from that source code, right? So there is a gap there. So that's what I believe, that smart contracts should be human readable on the one hand. On the other hand, thinking, IELE may be the answer currently, but it may not be the final answer, right? If we look into the future, I would like into the future, to be honest, to have contracts written directly as case specifications. When we verify, let's say, EVM contracts, again, if you go to the web page that I mentioned before, we explain how we verify contracts. You have to come up with a specification describing what your contract does. Like for ERC20 tokens, for example, we have to come up with a specification, the exact behavior, describing the exact behavior of all the functions that are being provided by the ERC token implementation. What transfer does, what allowance does, what balance does, everything. And those specifications are actually executable. I can run them with the K framework. Right? I can run them, and then also we take the solidity or the EVM code and we verify that the EVM code indeed meets these specifications. My question is, why to even have this code, the EVM code? Oops, John, I think I lost you.
No, I'm here.
Oh, you're here. I lost the image. Right. So my question then is why to do the same thing twice, right? So why to have a specification of what the contract should do?
Yep.
That I trust because it's executable and looks good, human readable, abstract.
Absolutely.
And then also to have the low-level implementation on the other hand. And then to verify the low-level implementation implements correctly the specification. I would like to execute directly the specifications. And all these specifications are based on rewrite rules. Each behavior is captured as a rewrite rule, saying that if you encounter this particular command, let's say transfer from A to B value V, then you do these checks and then you modify the store like this. You modify the accounts like this, the store like this, right? So you say exactly what to do in terms of how you transform the state. It's like a rewrite rule, transforming the state into the next state. I would like to write contracts like that. I would like a future where people write their contracts directly in a language like K, or maybe something else. K may not be the final answer either, but where you write the languages, your contracts, in using some form of rewrite, term rewriting system, because rewrites are already like transactions, right? So you invoke, they are like parametric transactions waiting to be instantiated, right? So there is a very, very, very close relationship between transactions as they happen on the blockchain and rewrite rules that we use to define the semantics of K, the semantics of different languages, and to write specifications and all that. So why not use these rules only and then push a button and generate everything from there, right? Generate the actual code that runs. I maybe even generate the consensus protocol, the consensus algorithm under the hood that already incorporates basically the best consensus algorithm for your contract, as opposed to having a fixed consensus algorithm for the entire blockchain, right? So I'm a firm believer in correct by construction things. Right, and I would like to just start with what I want, my executable specification of the contract, and that to actually be the contract, and then push the button and generate everything automatically. I had an interesting discussion with Vlad Zamfir yesterday, who is trying to do something similar with respect to consensus protocols, right? Where you have some rules describing at a high level what kind of consensus protocol you want, and then push the button and generate the correct by construction implementation of the protocol, which is very nice. But I think it can go all the way. Right? That's very nice, right? So very nice without any but, right? If he can make that work, that's great. What I would like, on the other hand, is to do the same at the language level, right? To have smart contracts written in this style, and then to generate from there directly the entire thing, the entire code. So as a user, you don't have to worry about any of the compilation or the translation execution pipeline. You only worry about the high level contract describing what you want to do, and that should be in an executable style. And I think this is somehow the philosophy also of people who develop functional languages for smart contracts like Plutus. They also think that, hey, these programs are very high level, and you write what you mean what you write. It's very clear. There is nothing to prove because it's what you want by construction. But in my view, functional languages are still languages, and lambda calculus itself is still just a rewrite rule, really. The beta reduction, when you apply a function to an argument, you actually do rewriting. So I actually think of rewriting as a higher level computational model, which allows you to choose your computation granularity of your desired language. As opposed to even languages like Plutus, they still force you to reduce your high-level computation granularity to the computation granularity of Plutus or of the Haskell or whatever functional language you use down there. So it's still not like you express exactly what you want, including the computation granularity that you want. But with writing, you have this this option, right? You can describe in one rule. One rule is one step only, right? So I can in one step match everything I need from the state, from the configuration, and then in one step I perform my transformation, my transaction. And I really love writing as a computational model, and also as a specification model at the same time. So there is no gap between implementation and specification when you use writing. And then since there is no gap, why not write smart contracts directly that way? That's you gave me the freedom to think freely and That's how I would like to see things in the end, and not worry about any programming language at all, actually, in the end. Because all these programming languages like Solidity, JavaScript, in the end, yes, they give you the benefit of having made some choices for you. Use a for loop for this. There are some design patterns how you write things. So it kind of tells you how to do things. But that comes always at a cost, namely that you can make mistakes as a programmer.
Yeah.
And we do make mistakes as programmers. You can also make mistakes when you write specifications, but I think the likelihood to make mistakes there, is much lower. The same way in real life, you can make mistakes, right? But it's okay to make a mistake in real life. But what is not okay is to run into a problem in real life because of a technological unexpected issue, right? And that's when things get annoying, and that's how we get problems with compilers having unexpected errors, or the coding. When I code, I actually implemented something else, not what I really meant. With a specification, writing things directly at the specification level gives you the freedom to lift the mistakes at the conceptual level. Where if you make a mistake, you made a mistake and you are aware of it. As opposed to having the mistake happen at a lower level where you don't have any control over.
Very
all right,
good.
That was probably longer than you wanted.
No, it's all good. I think that's kind of wraps us up for today, Grigore. So thank you so much for your time. It's lovely to see you. I do like your cap. That's very smart. That's good.
Yeah, we just got it new, so now I wear it. I like to joke that this is my business hat and this is my academic hat.
Okay.
When I go to conferences, this is my academic hat. This is my business hat.
You could almost go unrecognized. You put that on and some sunglasses.
Right.
No, really,
right,
really nice to meet you, and really nice
good
chatting.
questions, very good questions.
Thank you ever so much. Really appreciate your time. Know how busy you are, and I'm sure everybody's going to appreciate it in the community as well.
You too. Thank you. I enjoyed answering these questions.
Thank
Bye-bye.
you. Have a great day. Take care.